Welcome to section 2 of today's workshop. If you're just joining us, I'd like to introduce myself. I'm today's moderator, Renji Chen. I work at Lawrence Berkeley National Lab. Today we have 2 sections. So section 1, we already talked about how to control and mitigate indoor PM exposure. We're starting section 2 now on occupant responses to indoor PM, where the focus is on how to bring control and mitigation into practices, considering human behavior and also public health. So our sections are structured such that there's 3 presentations. We will have gather all 3 speakers, and if the speakers from our early morning section together for a final discussion in a roundtable. So there'll be time for question and answer, and we encourage questions from the audience. You can submit them using the chat function in Zoom. And reminder that you should focus your question around the presentation and the topics of discussion today. So I'd like to introduce our first speaker. Stuart Batterman is a professor in environmental health sciences and global public health at the University of Michigan School of Public Health. Today he's going to talk about portable air cleaners and human behavior, and it will draw from some field studies that he's done in schools and homes and insights on what makes for a successful behavioral intervention. Stuart?
Thank you, Renji. Can you hear me okay?
Yep.
Super. Okay. So today I want to cover the topics shown here. I want to describe how to clean the air in your home, the importance of behavior. We're going to focus on portable air filters and discuss their effectiveness and some of the behavioral aspects of these. As Renji said, we've done a number of field studies, and this is the typical type of guidance that we would give folks, for example, who have children that have asthma. In Detroit, we would say don't smoke indoors, don't allow others to smoke. If you have a portable filter, put it in your child's room, use it all the time. We'd give them instructions on using microfiber rags to clean, use a vacuum cleaner instead of a broom, use a good furnace filter, don't use air fresheners, don't use mothballs. We tell them a lot of things to do. And the point here is these are all behaviors that we're trying to alter. And so what we're really trying to do is get people to change their behavior to improve their indoor environment and ultimately their health, or in many of our studies, their children's health. Now, in the public health world, we call this an intervention, and we know that multi-level interventions or multi-level approaches to changing behavior can be most effective. And what I mean by this is, first, we have an individual level, identifying people at high risk. For example, the children with asthma would be an individual level target. We also look at approaches using community-based, the community setting. This allows us to modify the environment, to use peer behaviors, sometimes rules and other things. And typically in our intervention studies, we combine the individual and the community level to use a community health worker, for example, a trusted member of the community to try to change behavior. And then we have national or regional level levels too for changing behavior. Now, these kinds of behavioral changes apply to many types of decisions regarding indoor emissions, exhaust fan operation, HVAC, and filters. And we know in a very detailed way the engineering system of air filtration. And as we've heard earlier today, we need to take a systems approach. I also want to emphasize that each environment is unique and each community is unique. And the major take home here, though, is we need to identify effective ways to change behavior. Now, in drawing from the literature in terms of interventions, we have kind of a conceptual diagram for thinking about behavior change. In red, I've listed some of the elements of behavioral change. Ultimately, what we want to do is to improve health by lowering PM levels. And this depends on behaviors which can be set off by an intervention, and we can move through the different steps in this simplified diagram, recognizing that the effectiveness of the intervention depends on the context, the population, the extent that this is reached to different parties, the engagement, and so forth. And all of this, we want to affect the outcome again, in this case of using filters to reduce PM concentrations. Now, this is a simplified diagram, but it does represent the fact that changing behavior is a multi-level, indirect and complex approach, and we often fail. And we have some very good successes. For example, people have largely stopped smoking indoors and in commercial buildings and office buildings and so forth, but this took many, many years. Okay, to bring it back to portable air cleaners, on the left I have a picture of a portable air system, air cleaner. This is a self-contained and portable device. It cleans the air in a particular space where it's positioned. We also, of course, have induct air cleaners, typically a furnace filter like this. And in general, it's recommended that you would use a whole building or a whole space approach using some sort of induct filter. But there are applications where perhaps portable air cleaners might be the only option that you have, or a supplement to the induct air cleaners. In particular, you might choose portable units when the space doesn't have any filtration. For example, an older home with steam radiators, or one with baseboard heating or split systems or so forth. A second reason is when it's difficult or impossible to upgrade induct filters. A third reason is that additional cleaning in a space is desired to reduce the risk. And this might be because of the limited duty cycle of forced air systems, inadequate airflow to a space, local sources, or perhaps the perception that we have a critical environment or a susceptible individual. And then finally, in portable air cleaners might be used to remove gaseous and biological contaminants that wouldn't be removed by filters present in a central system. Now, how well do these portable units really work? Well, we know based on theory and experiment that they can substantially reduce PM exposures, but in practice, evaluations tend to be quite mixed. Often the filters don't live up to the expectations. And in terms of changing health, while there are studies that decrease symptoms, for example, asthma symptoms, many of the studies are inconsistent. Now, there are a lot of good reasons why we get this mixed result. Filters may not perform because their clean air delivery rate or PM removal may be inadequate for the space. Air change rates, opening windows and so forth are rarely documented. There are other concerns regarding sample size and limited monitoring and bypass and filter deterioration. And then filters are only effective if they're in fact used, if they have a high runtime. So we and others have done a number of filter studies, and I want to take a minute or two and discuss some of the results from a study done in Detroit. This is a low-income, largely environmental justice community. We recruited 126 families. We provided them with air filters. We provided them with additional cash to run the air filter. We placed the filters in the bedroom of the child who had asthma in these households. And we measured particulate matter, impact on health, and a bunch of other types of parameters were measured. We also took a data logger and inserted it into the portable air filter to capture the use history. This was part of an intervention study. We were looking at children with persistent asthma using a community-based participatory research approach. Some of the details of the study are here. It's not too important for this presentation, but it's a fairly comprehensive study where we had divided the group into three sets. The first set was a control, the second set received the air filter, and the third set received the air filter plus an air conditioner to be able to control the ventilation in the summertime. Many of these homes were not air conditioned. And a community health worker was engaged, so this included both the individual level intervention as well as the community intervention via the community health worker. So how well did the filters work in this application? I'm showing here traces over about a week-long period of particle number counts in a submicron and a 1 to 5 micron. We can see that on introduction of the filter, levels dropped quite dramatically. And the filters produced a very high level of PM reductions. Again, this is in the child's bedroom when the filter was operating, and we got reductions on the order of 50 to 80 or so percent. And we had some differences with the reduction in the smaller versus larger particles, but overall, this is quite an effective reduction. Now, over the entire study, things were much more mixed. Here I'm showing a seasonal analysis of levels in controls, which averaged about 28 micrograms per cubic meter. And then in both the standard and enhanced, over the time of the study, all the seasons, levels were halved to about 12 to 14 micrograms, representing about a 50% reduction of PM during the monitoring period. So this is quite good news, and it seemed quite effective for us. And I want to say, here's another filter study. And in fact, in preparing for this talk, I think Lance Wallace shared a list of over 100 filter studies that were done prior to about 2008. There's probably been another 100 since then. Really, what's new? Well, I could argue that we had a susceptible population with a very high rate of asthma, and that we had, a nice study design. But really what I want to argue here is that we monitored how filters were actually used. And I think we found that behavior was a substantial source of variation in the study. In particular, when we looked at the use of the filters during the monitoring period, we had quite high use, about 97% initially, dropped off a little bit to about 70% over the next season and subsequent seasons of the study. And there's significant variability across homes. Some homes would barely use the filter, perhaps 10 or 20% of the time. Others would use it 100% of the time, as was urged via the community health worker. So perhaps we're seeing a little bit of a novelty effect in terms of a decrease in the use. Now, this is a 3 or 4 or 5 month period in between these monitoring periods. What happened then? Well, this was the surprise. Here we found filter use plummeted. Overall, we had filter use of only about 28% of the time, and this even decreased a bit over time as well. This low use is problematic. Possibly a number of reasons could account for this. One of the interesting factors was in the midst of the study, the local electric utility increased their rates, and the household saw their electric bill go up, and they're thinking, hey, it's our air filter. We were providing them funds for the air filter. So there are other reasons too. We have observation or Hawthorne or good behavior effects reflecting that participants know we expect them to have the filter on, so they put them on when they know we're going to come around. And then there's the economy effect due to the electricity price. And then finally, there's some issues of noise and draft associated with the filters, which bothered some individuals. But this large drop in runtime or use was a surprise. The electricity cost has been documented by others. This is just a slide from US EPA indicating that HEPA filters, these standalone units, could cost a couple $100 a year. The variability of use was dramatic. We had some users that used the filters all of the time when they were being observed, and all of the time when they were not being observed on the right panel. We had others that used the filters very little both times, and then we had a crazy quilt combination of folks that used them or didn't use them when they weren't observed. So there's a lot going on here. So overall, this particular study found portable filters can work when they're used. That's not too surprising. But the effectiveness depends on their use, and in particular on their behavior. And as I've illustrated, the patterns of filter use are quite dynamic, and they vary greatly across the households. Overall, though, I would say filter use was unexpectedly low. Now, the other part of this study, which I'm not going to spend much time on, was looking at asthma symptoms and some biomarkers and so forth. And perhaps because of the low runtime, we didn't see any significant impact on these children in terms of the symptoms and inflammatory markers that we were looking at. And of course, there's many possible reasons for this. The lack of filter use causes what we term exposure misclassification. But I think it's also important to recognize that the indoor environment is just one of multiple exposure compartments, and you'd like to address the school, the transport, play outdoors, and so forth. So to follow that up, we constructed a model using engineering style Monte Carlo simulations to understand what is the indoor concentrations from outdoor sources coming in, penetrating through the building envelope, and then imposing filters, either furnace type filters or standalone portable filters, and use this to calculate the health benefits using health impact assessment types of approaches, and to essentially calculate marginal costs and benefits of filters of their use. This was done for both schools, where we upped the filters from MERV 5 to 8 and 12, and relevant for today, for adding filtration to bedrooms and living rooms and using standalone filters. So in these scenarios, I'm discussing the use of two standalone filters, one in the child's bedroom and one in the living room. And then we use the HIA methods to estimate the asthma-related health benefits. And overall, we can summarize some of the results in a reduction in the disability-adjusted life years. And this is about a 16% reduction, which is predicted based on the use of a filter in a space that had previously very little, if any, filtration. The marginal costs of having that filter is listed in the box here. For the standalone filters, it's nearly $500 per year, accounting for electricity, the initial costs, and filter replacements. It's cheaper to use forced air systems by simply adding a filter into place. Now, these health benefits are only looking at asthma symptoms, cough and wheeze, shortness of breath, ED, emergency department visits. There can be other benefits, of course, associated with reduction in particulate matter level that's not included in this presentation. So overall, we estimate that the PM 2.5 exposure accounts for about 6.5% of asthma outcomes in children in the Detroit, Michigan area. Reducing PM levels using filters in classrooms would reduce the asthma burden by roughly 8 to 17%, and doing the same in homes would be 11 to 16% reduction for, again, these asthma burdens. And I've already talked about the marginal costs. So to summarize this particular filter application, provision of portable filters should be considered an active intervention that requires a behavioral change. And again, a multi-level intervention where you're addressing both the individual and the community may be the most effective approach. Our experience indicates that filter use or runtime should be monitored in trials to reduce exposure misclassification. And quite reasonably, I think that low runtime may help explain some of the variations seen in some of the previous studies. Now, turning to research needs, we need to understand what makes for a successful behavioral intervention. And I should say that this is not just for portable air cleaners, but it's range hoods, it's other types of exhaust systems, and so forth. Well, the literature indicates that simple messaging is important. We've got, in the last year and third, I think, many messages dealing with masking and distancing and so forth. It needs to be simple, but this still is not a trivial matter, obviously. We hope that people will learn and act on information, but providing information is no guarantee that people will change their behavior. The exception to this seems to be that if the message is permeated or impacted so deeply that it can't be ignored, then behavior will change. But we're not at that point yet with the understanding of PM indoors. And then this can also be facilitated by consideration of externalities. For example, if your action is perceived to either help or hurt others, if your peers are doing this, and if you take a multi-level approach, then this can improve the success or likelihood of the success of a behavioral intervention. Finally, there's a set of questions concerning engineering portable air cleaners to encourage appropriate behaviors, to make them more acceptable and to make their use increased. So the technology could be reduced in size, cost, in terms of noise and drafts. All of this will increase their technical acceptability. Providing information and enhancing the awareness with respect to filters might encourage people to buy them, to use them, to encourage these good behaviors. Some of this might be done by incorporating both use or runtime information and IAQ sensors in units, and I think we're going to talk about sensors in the next discussion, and then making this intelligible to the user. A final research need is to improve the controls for these portable air cleaners. Running them all the time is one option, but using automatic or smart or timer-oriented or PM or occupant sensors in these systems would provide a number of advantages compared to manual controls, for example, reducing the cost and nuisance impacts. So I wanted to cover a little bit about some of the studies and acknowledge first follow-up information in these references, and then all the contributors to this work. Thank you very much.
Well, thank you. I think we are a couple minutes early, so maybe we'll answer a quick clarifying question. Can you help us tell the difference between an air cleaner, an air purifier, air scrubber, some of the terminologies that consumers are seeing?
Yeah, so I think a lot of these terms are used interchangeably, and what I've been talking about are largely mechanical filters used to remove particulate matter. There are a wide range of things that are marketed that are called purifiers, disinfecting systems, and so forth. The only ones that I'm really talking about here again are addressing particulate matter. There are ionizers, there are sterilizers, there are plasma systems. The literature on this is not consistent, and I would refer folks to guidance which is available from EPA and others with respect to both the language as well as the technology and the performance behind these technologies.
Great, thank you. And then there's also a question about the health impact assessment. How was it done? Is it a self-report questionnaire or is it something else?
Right, so what I described was two things. With respect to the specific study of the children with asthma, this was an epidemiological study, so we had both symptom reports, this would be questionnaires, as well as pulmonary function tests and other clinical measures. The second piece that I showed, where I was comparing the impact of upgrading a filter in schools and in homes, used a burden of disease approach, which is basically taking dose response information from the literature, from meta studies, for example, or some of the better studies, and applying that to predicted levels of particulate matter in the scenarios that we were analyzing.
Right. All right. Thank you.